Thank you, Sahan sir. And good evening, good afternoon, and good morning. This is the 1925th day of continuous webinar conducted by International Forum for Promoting Homeopathy. Today, our guest is Dr. SURAJ SINGH BHADORIA. Let us begin the session with 1 minute silent prayer. Thank you all. The International Forum for Promoting Homeopathy comprises of homeopathic lovers, students, and doctors, and we have 3 sessions every day. The first session of the day is already over in Hindi from 7:30 to 8:30. From 8:30 to 9:30, we have the international session in English, and from 9:30 to 10:30, we have the local language session in Malayalam. We are uploading the videos of the same on the very next day itself, so that those who missed the session can watch it again, and you can subscribe the same without paying any money. The purpose of the forum is to take homeopathy to every home around the world. And we are very happy to invite our today's guest. It is Dr. SURAJ SINGH BHADORIA. And the doctor has completed MD and now doing PhD. That's why he's known as PhD scholar. And he is working as the assistant professor, Department of Homeopathic Pharmacy, Pearl Institute of Homeopathy and Research, Vadodara, Gujarat. Doctor has made so many sessions in this forum. All were connected with the research papers. He is such a young, dynamic persons like Suraj Singh Bahodia is the need of the hour because a lot of people are saying that homeopathy is a pseudoscience, but these kind of young generation doctors can prove the world that homeopathy is purely scientific. It is the purest science, scientific system among the world. So we are very happy to invite today. Doctor will be talking about materials science in homeopathy. That's a very, very different subject. So we proudly welcome you to this stage, Doc, to begin the session. Welcome. And let me make you co-host. 1 minute. Okay, you can begin. Sorry, please unmute.
Am I audible, sir?
Yes, yes, you're audible.
Okay. Now I am going to share my PPT with you
Yes,
all.
yes.
Is it visible to all, sir?
Yes, yes, it's coming. Okay, it's ready. It's visible. You
Okay,
can make
sir.
it.
It is visible to all, sir, na?
Yes, you can make it
Okay.
large. You can make it large.
Okay. Now today we are going to start it with the discussion about this material sciences in the homeopathy. So this is very important aspect to understand the beauty of homeopathy, to understand the various evidences and the main scientific perspective of the ultra high dilutions and how the atoms and the molecules and all these electrons make a different pyramidal and different material structures for facilitating their action in the living entity. Now the definition is the material science is the interdisciplinary field. It is one of the way to approaches in a different study and the backgrounds of minutest particles. So this study always show the relationship between the material's structure and its properties. So the properties plays a major role. So here the properties are the physical properties, the chemical properties, the dynamic properties. So the dynamic properties exhibit with the ultra high dilutions or the homeopathic sciences. So this is the material science, and this material science generally it combines and entangle with the physics and the chemistry and the engineering sciences to make the different division of the discovery, the development, and the making a design and the creation of the new material to solve the many problems which are regarding with the medicine and the energy and the electronics. Generally in the western country there are so many post-doctoral fellowship or the doctoral fellowship, JRF and SRF and the research fellow program. So generally these people are mainly exhibits with the material sciences, the evidence-based practices in the field of the physics, chemistry, and the biomedicine or the biotechnology. So what we want to do now, we want to inculcate such material sciences and the field of evidence-based practices with the homeopathy. So this is very very important to understand about the material science. That is our aim and objective, because when we know about the pattern of arrangement of the different molecules and the atomic structure with the different linings of the electrons, so ultimately we are going to make the different categorization and the classification of the subjects and the materials on the basis of their physical and the chemical properties. So this plays a major role. Next slide. Now, what are the material science? Generally, it possesses the four different properties. The four different pillars of these material sciences are structures, what are the pattern of arrangement, how it looks, how it seems. So these are the morphological features. The second one is the properties, the physical property, the chemical property, their pharmacological action. So this plays a major properties and the what we can say the dimensions of the material science. Next is the performance and the processing. So processing generally exhibits with the level of the migration and the movement and the intimation of such minute and the smallest particles in the media of clustering molecules. So these are the processing and the field of the science which deals with the materials or the atomic structures. So these are the main pillars of material science: the structures, the morphological features, the properties, the physical and the chemical and the electromagnetic or the magnetic properties, and the performance and the processing. So these all are the material sciences. Now the next one is, what are the structure and properties? These are generally regarding with the materials, atomic and the molecular structures which exhibits with the mechanical, electrical, thermal and the optical properties. So these all are regarding with the different dimensions and the properties of such materials. And the processing and performance means when we investigate, when we find out such processing techniques which affect the material properties. Suppose if the pressure is there, if the temperature is there, if the volume is there, if the mass is there, if the velocity is there. So these all are the various aspects and the factors which affecting the various materials properties, and they also influence the specific application of such materials and the properties. So these are the processing and the performance of such materials and the atomic structures. The material design generally they develop in a different specific dimension with the different properties and the finding a new application for the existing ones. So this will give you an idea about the material design. This will give you an idea about the various aspects of such entanglement and the dimensions and the propagations of such atomic and the molecular structures. Next one is the failure of analysis. So generally the failure of analysis is regarding with the researching of various materials which fails to unexpectedly to improve their reliability. So generally this searching and the research in the materials, it improves the reliability, because if suppose when we talk about aldehyde dilutions, so there is no such molecular and the atomic structures. So we are unable to showcase the beauty of such and molecular structures and the minute structures. So we always talk about the plausibility phenomena, epitaxy phenomena, the water memory, water molecular memory. So these all are just a hypothetical part. So these are failures in our analysis, because now we are only talk about the philosophical background, we are only talk about the history, we are only talk about the various sections and the aphorisms of the organon of medicine. But what about the basic principles of the standardization, the quantification, the qualification of such materials doses? So that we want to need to progress our homeopathy, to make our homeopathy as evidence based medicine, and that we want to conclude with the different aspect and the different dimension and the different structural ways for making the material dose in a some minutest and the smallest or the infinitesimal dose in a different angle entanglement of their physical and the chemical and the electromagnetic properties, to showcase the specific design, to showcase the specific performance, to showcase the specific action in a specific cell, in a specific tissue, along with the living entity or this living world. So that we want to conclude with the material science. So here, unfortunately, we are failed to explore and to showcase the beauty of such minute and the massless structures in terms of the reliability. So that's why now WHO and the whole world, they are not recognizing homeopathy as a evidence-based medicine or the scientific practicing. They thought that it is only a plausibility, it is a quack, and it is a magic effect. It is a placebo effect. So we don't want to showcase that. We also want to showcase the beauty of our ultra high dilutions. Now, what are the properties? The physical properties, chemical property, which regards with the chemistry, the basic chemical reactions, the compatibility of various atoms and the molecules. Next is the biomedical engineering, which again plays a major role. What is biomedical engineering? Suppose if we make a coil, if we make a certain instruments, if we make a certain devices, so in that way we are going to investigate and find out the various disease aspect in the living entity. So biomedical engineering plays a major role. For example, if we talk about the CT scan, if we talk about the MRI machine, if we talk about the UV visible spectroscopy, we talk about any type of investigational tool. So these are probably used for the diagnosis, for the identification, for making the specification in the markers, in the biological samples, for the diagnosis of various disease and the pathological conditions. So these are the biomedical engineering. The nanotechnology, again, it is a huge branch of the science of this modern era. So the nanotechnology device and it defines and makes the different dimensions and the entanglement of the smallest minute invisible structures. So that we want to synthesize such structures in our ultra high dilutions, in our medicine, in our homeopathic tinctures, in drugs, in medicine. So in this nanotechnology, again we have so many instruments. For example, in our Parul University we have a micro nano lab. So in this lab we have SAM, we have a scanning electron microscope, and we have XRD. So through this instrument and this sensitive investigations, we are going to identifying the various synthesized materials in our solvent system. So this is towards the study of nanotechnology. Next is the mechanical engineering. Generally deals with the formulary and the design of various structures and the materials which regards with the mechanical action, with the physical properties. So generally mechanical engineering also and entangled and make a huge collaboration with the material sciences, because whenever they prepare any coils and the wiring and any type of instrumentations and the softwares, so generally these are the mechanical devices which embodying with the material doses and the various dimensions of such minute structures. And the electrical engineering generally regards with the electromagnetic and the electrical properties of such materials which exhibits in a different shells from lower to higher and higher to lower, with gaining on the release of the energy. So these are the various parameters and the pillars of the material sciences. Now here, where is the homeopathy? Because now today our session is material science in homeopathy. So here, when we talk about this one, the nanotechnology, this section. So the nanotechnology and the chemistry branch, these are the main equipment which we used in our homeopathic preparation or the homeopathic pharmacy. So these are the main aspect of the material science in homeopathy. Suppose if we prepare any nanoparticles in ultra high dilutions or the mother tinctures or the lower attenuations, so these are embedding with the different physical and the chemical properties of such materials, the chemical and the physical properties of solute, as well as the chemical and physical properties of solvent. So these are the chemical part, these are the chemistry part which regards and regulates with the material science in homeopathy. And the nanotechnology, these are the synthesis, these are the preparation, these are the creation of such minute and the massless structures with different physical and the chemical properties. So these are the material science. So that we want to make the entanglement of the homeopathy with the material science, then only we can say yes, homeopathic is evidence based medicine. But yet in ultra high dilution we have a certain limitation in terms of atomic structure, in terms of molecules. But when we talk about mother tinctures, because these are the base from which we prepare a further and other potencies. So from this mother tincture, we can make this material science. We can make the reflection of such beautiful properties and the collaboration and the pattern of arrangement of such atomic and the phytoconstituents and some active principles of this drug and medicinal substances. So that we want to showcase this. So these are the main pillar and the background and the history of the material science with the different branches with the multidisciplinary way. Now, the types of material studies. What we want to do? The number one is the metals and the alloys. So, generally, it is used in the mechanical field, in the mechanical and the engineering devices. So, these are the metals and the alloys. So, generally, this embedding with the different preparations of the atomic and the molecular and the crystalline structure, which make the specific structure and the design of that metal. So this is having a different properties. These are showcasing a different patterns in a their action, in their arrangement, and in their way of progression. So this is the metals and alloys, ceramics and the glasses, polymers. These are in a huge form. Generally, in our plastic one, when we dispense our medicine in the plastic file, so these are generally made with the different heterogeneous and the various polymeric chain or polymerous structures. So these are not stable in a prolonged interval, but yet again the polymers, these heterogeneous structures also made by these material sciences in the different department of this chemistry and the physics. So this is the polymerization. Next is the composite. So similarly composites made by some herbal extract, composite also made by some what we can say the organic substances, composite also made by some inorganic substances, composite embedding and resembles with the different physics and the chemical properties and the orientation of such materials in a different compound, in a different matter. So this composites define you the characterization and the what we can say the significance values of the solute and the solvent. So this composites plays a major role. Suppose if we prepare a shampoo, so in our homeopathic medicated shampoo we have thuja extract, we have adium cipa, we have jaborandi, we have cantharis, we have staphylos agria. So these are the different composite from the different family, from the different category, from the different origin, from the different chemical and their physical properties. So when this A plus B plus C plus D form, so it will unite and give a mixture. In some way, it will give you a different dimensions of a synergistic effect. So these are the properties of composite. Next is the electronic, magnetic, optical material. So these are the properties and the types of material which we use in material sciences. So generally it regards with the different progression and what we can say the stability of such material. So the electrical property, the magnetic property, the optical property, these all are depending on the stability of material. If our material is more stable, if it is more stable in terms of their physics and chemical properties, so their electronic and the magnetic and the optical dimensions generally they are also stable as per the time interval. So here the time plays a major role in stability of such material sciences. Whereas the nanomaterials like graphenes and the carbon nanotubes, these are the materials which are we commonly used in the various investigational tools and the devices and the machinery which are commonly used for the pharmaceutical preparations for the pharmacy perspective. So these are the nanomaterials. Okay, suppose if we have a UV visible spectrophotometer, Suppose if we have a XRD, if we have a HPTLC machine, if we have a FTIR machine, if we have an electron microscope like SEM and TEM, so they have a different formulation of these nanotubes, the graphene sheet, the carbon element, and the graphite. So these are the nanomaterials. So generally these are made for the making configuration of such material, which are used to investigate and to make specification in identification of the materials in given solvent system. So these are very very important part. The biomaterial generally it regards with the artificial tissues or artificial cells or in vitro studies. So these are the biomaterials. Now there is a scope of homeopathy. How? Suppose if we want to cultivate and grow any artificial tissue, so the main aspect is the media. So here, if we prepare a media which is homeopathic medicated, suppose if we prepare a homeopathic culture media. So homeopathic culture media is a media which contains all nitrogen, phosphorus, potassium, iron, carbon, magnesium, oxygen. So these all are the basic elements and composite which responsible for the growth of such artificial tissues, because we want to cultivate it. So here the scope of homeopathy plays a major role, because today our topic is not only material science, we have a material science or the scope of material science in homeopathy. So where is the scope? So suppose if we want to cultivate any artificial plant tissue, animal tissue, a human tissue. So the culture media plays a major role. If the culture media is very good and very free from all contamination, so they can easily cultivate and grow such tissues which are used for further evolutions and the further method of mechanism. So that we want to inculcate and make the collaboration of homeopathy with the bio science and the biotechnology. So similarly in agricultural sciences they have a biotechnology. So they go for the hybrid, they go for the hybridization, they go for the making cultivation of plant tissue. So here again, as per agro homeopathy, we have so many medicine, we have so many families and so many drugs which are useful in the growth and the cultivation of the crops in a different yields, in a different plants, in a different flowerings and plant disease, the plant pathology. So here the scope of homeopathy is very vast. So this but biomaterial again plays a major role. Next one is the smart materials and the sensor. So what are the smart materials and sensors? Generally, these are the materials, these are such atomic and the molecular structures which shown their specific action, their specific pharmacological action, their specific s- sphere of action in any material dose. That's why they are known as a smart materials. They are a sensors. They are very highly sophisticated and sensitive instruments. That's why the name is suggested as the smart material, the sensitive material, the sensitive sensitizer or the sensors, because they are very sensitive to a particular temperature, they are very sensitive to a particular pressure, they are very sensitive to a particular instrument, they are very sensitive to a particular stimuli, they are very sensitive to a particular solvent, they are very sensitive to a particular vibrational or a frequency, they are very sensitive to a particular property of a material. So these are the smart materials and the sensors. Suppose if we have FTIR, that is IR spectroscopy. Again, in our R&D cell, the Parul University Research and Development Cell, we have this FTIR machine. So there is one lens, and when we put the one drop of the liquid or any mother tincture or any solvent in the oil over this lens of FTIR, so this lens is sensitive to such materials and their properties and their electromagnetic field. So they will give you the different dimensions for the identification of the functional groups. So these are the smart materials and the sensitizer or the sensors which plays a major role in the field of biomaterial, in field of nanomaterial, in field of electromagnetic materials, optical, magnetic, composites, polymers, ceramic, glasses, metals, alloys, everything. So these are very very important classification. And the what we can say the Moving towards the next slide. Now you can see. Now, what are the material science and engineering? So first we have the engineering design. In engineering design, now you can see we have to create a certain design. We have to create a certain structures which are made by such materials and the atomic and the crystalline structure and the fibers and the various coils and the various designs of such minutest and the minutest structure. So these are the engineering design. Okay, we have chemistry, we have physics, we have crystallography, we have bio and environmental sciences, we have chemical engineering, we have architecture, we have mechanical civil engineering. So here this bio and environmental science, this one, bio and environmental science, and the physics and the chemistry, these are again the main pillar in our homeopathic sciences. Suppose if we talk about the potentization, so when we do trituration, we do succussion, trituration for solid potency, succussion for the liquid potency. So this succussion and the force, this is a force in acceleration. So this force in acceleration, the capital F with the arrow at the superscript, this will give you the acceleration to convert the mass into massless structure. So this mass particle converting, while it converting into massless structure, so it convert into the small micro emulsion. Now this small micro emulsion again by this same force in acceleration gets converted into super micro emulsion. Now again by this force in acceleration at every equal downward strokes, this super micro emulsions gets converted into the isotopic molecules. And these isotopic molecules, they have a specific atomic weight and the molecular weight. So while this conversion of mass into electromagnetic and this microemulsion into isotopic molecules, now they gets converting into the minutest structure which are above the nanoparticles, above the Avogadro number. So they possesses various electromagnetic property and the various dynamic property. So this is the relation of physics in potentization, the scientific evidence in potentization. So this is the science of physics. This is the explanation of the scientific background of potentization. So again in physics field, you can see the force, the volume, the mass of massless structure, and the mass of the atoms and the molecules, and the momentum. What is momentum? It is the length of the traveling path. If a particle travel from A to B, so while what we can say measuring this length of the traveling particle, it is a momentum. ठीक है, तो this momentum, the velocity and the force and the volume, these are the major components for making our medicine or our aldehyde dilution or the method of potentization in a scientific, in a best way for approaching towards a material science. So this is a physics part. Now what is bio and environmental sciences? Generally it regards with the environmental medicine, it regards with the biomedicine. So generally we have again a huge scope in bio and environmental sciences. We have so many medicines which goes excellent work in such a bio and environmental conditions. So these all are the main aspect of material science and engineering background. Now what we can do in further way, when we talk about this compository, so how it forms. So generally in compository, these are made by a sequential arrangement of a different atomic and the molecular structures. So when these atoms combines, here you can see in the picture, when these atoms combines, so they form a molecules, and when these molecules combine, they form a crystals, a big particle, a huge particle as compared to the atomic structure. So in this atomic structure, you can see the different valency of the electrons in germanium atom. So this is a type of atom in which you can see a different pattern of arrangement of electrons in lower shell, in higher shell. As per the Bohr's atomic theory, when electrons jump from lower to higher, so they gain the energy. Okay, and when electrons jump from higher to lower, so they release the energy. So one is endo and another one is exo. Endo is to gain the energy, exo is to release the energy. So you can see this different valencies of such atoms. Now these are the cross sectional of germanium crystals, because again when these atoms combine they form a molecule, and this whole cluster of this molecule, this will give you a different pattern of arrangement of such matter. So they have this cross sectional study of such material science. In the middle part you can see the nucleus of this germanium atom. So this nucleus exhibit with the protons and neutrons. So generally these are the main aspect of the atomic structure in the germanium atom, which arrange in a sequential pattern, in a pattern of uniform and a unidirectional flow. You can see there is no zigzag pattern. We have a different pattern of arrangement of such atoms and the material sciences. In some way they have non-uniform, or what we can say the zigzag pattern. In some way they have a uniform direction, but in this slide, in this picture, you can see the uniformity in the arrangement of these atoms, the arrangement of their electrons, the arrangement of these clusters, arrangement of these molecules with this cross sectional and the surface of this material. Now in this there are three main property. The first one is energy, such as heat or light, which uh, falls over the electrons to leave a positive hole. So while migration of these electrons from one place to another place, suppose if electrons travel from A to B, so while traveling from A to B, they gain or release the energy. They affects due to the light, they affect due to the temperature, they affect due to the pressure, they affect due to the volume. So these are the first main property of such material science. Second is nearby electrons, they jump to fill the positive holes, leaving a new positive hole. So when they jump from one to another, so they make a hole and they fulfill another hole. So when they transfer from A to B, so they fulfill the hole in B while leaving a hole in A. So these are the migration of electrons. So these are also called nanomocks. Generally, we have a one philosophy and we have a one hypothesis. In a nanomocks, nanoparticles showcasing a different properties at different levels due to temperature and pressure. Similarly, in this material science, when these electrons travels from one space to another space, so they fulfill or fill the spaces in another one while leaving is hole in another one. So these are the theory of electron jumping and what we can say the shifting of electrons. So this shifting of electrons changing the valencies of such atoms. So if one carry the electron, so they carry positive. If someone gives the electron, so they carry positive, cation and anion. So similarly, this formulary and this compository of material sciences exhibit a main physical and the chemical property which defines their basic properties and basic characterization and the significance for their use, for their application, because ultimately we want application part. So this application depends on their physical property, this application depends on their chemical property, this application depends on their pattern of arrangement, this application depends on their migration, their what we can say the progression of electrons, the progression of atomic structure, the progression of crystalline structure within the material. So this plays a major role. The third one is the third electron moves to space vacant by second electron, leaving a positive hole. The hole has moved two atoms. So these are what a replacing of electrons. So one at electron replaced to another, another replaced by another. So these are the replacement. These are generally a shifting, a pattern of the changing the valencies, the changing the holes, the changing the different places. So these are needed for making the stability in a material science, because if there is no migration of electrons, so they are not changing the valencies, they are not gaining or releasing the energy, they are not filling the holes, they are not leaving the holes. So ultimately the material stability goes off. So generally, what we can say in our aldehyde addition, they are more stable. Why? Because they are above the Avogadro number. They are at the level of plausibility phenomena. They are at the level of Potter memory. So ultimately, there are no such holes and no such theory of migration of electron and nanomorphs. So generally, there is a theory of the aldehyde addition. There is a theory of the migration and the exhibition of energy, the dynamic power. So that's why the aldehyde dilution, they are more stable as compared to the mother tinctures. So these are the main cause why the mother tinctures are less effective as compared to the aldehyde dilution, because mother tinctures are just similar with the concentrated material dose. So the material tincture, the material dose, they exhibit all these electronic, the atomic, the electromagnetic, and this dynamic property. But ultimately, this aldehyde dilution, they are superimposed, they are above the material dose. So that's why their stability is more as compared to the material one. So these are the main aspect for discussing the compository. These are the main, what we can say, the pillars and the signs of the material of any particle of any substance. So that we want to study. Now you can see in electrical conductivity, so again this material change their shape, change their pattern of arrangement, change their orientation at different temperature, at different velocity, at different pressure, because ultimately when we talk about mass, so mass is what it is, density upon volume. So if more mass, more density, if less mass, more volume. So this mass equals to density upon volume. So generally, in any clustering, in any molecular structure, in any material dose, mass is generally a pyramid or the structure or the formulary of such atomics or the molecular dimensions. And what is the density? These are the compactabilities, these are the compact of these mass particles. And where is the volume? When these mass particles or the atoms occupy a space, these are a volume. Now this will change as per temperature, as per pressure, as per volume, as per the intensity of light also. So similarly, when we do trituration, so when we use solute and solvent, suppose if we use drug, that is solute, we use vehicle, which is solvent. So this 1 raised to 9 as per decimal scale, when we mix this in a 1 raised to 9 solute and solvent, and when we do trituration, which is the exhibition of force in acceleration with the velocity, so there is a movement of such particles from lower to higher shell. Now this is the momentum. Now we want to calculate the length of this mass particle into massless structure from leaving space to filling space. So that we want to calculate. So there is one formula, that is F equals to m naught Bp. So this is the Sun's formula. So in this Sun's formula, what we define, this force in acceleration, it accelerates the massless structure, the mass of massless structure, which is m naught, in a specific velocity and the momentum with the time interval. So this time and the temperature plays a major role. So this is the electrical conductivity. So when this atom and the molecule and the material dose travels from one to another, so they exhibit different electrical properties, they exhibit different electromagnetic properties. They generate these electromagnetic properties by the migration of electrons, by movement of electrons from one hole to another, from A to B, from B to C, from C to D. So these are the continuous process. So while migration, they somewhere they gain the energy, somewhere they release the energy. So while releasing or gaining, this phenomena exhibit the release of charged particles. So when these charged particles exhibit with the specific velocity and the acceleration and the momentum with the path length, they exhibit a electromagnetic field. Now this is the electrical conductivity. So every particle, when they migrate, when they change the position, when they change their orientation, when they change their structure, so they exhibit a different electrical conductivity. Got it my point? So that's why while doing trituration, this electrical conductivity, because ultimately while doing trituration, what are the forces? So the forces are, first, centrifugal force, centripetal force, center to periphery, periphery to center, because we are doing trituration like that in a mortar pestle. So when we triturate from center to periphery, then periphery to center, so these are centrifugal and centripetal force. Center to periphery, periphery to center. Gravitational force. Mechanical, because we are doing this in a mechanic, so this is the mechanical force. Okay, so these are the different forces which act during the trituration. So these are developing a different field of electricity and the electromagnetic property. And this electromagnetic property defines that particular property of material. And the application of such materials depends on the pattern of arrangement, the pattern of structure, the solubility and the stability of such materials in respect of temperature and the specific time. Next is materials level. Now, where is the materials level? Now, you can see in the pure science when we talk about length and time. So, suppose in this x axis we have length, and in this y-axis we have a time, because every particle travels in correspond to time. So this is quantum mechanics. So when this quantum mechanics, generally there is a role and the exhibition of electrons, the negative charge particles. So this quantum physics, when they affects with a specific length and the time, so they will give you a different molecular dimension, and the dynamic property of such molecular structure or the atoms and molecules at the specific length at specific time. Okay, suppose if we prepare a nanoparticles in Steffi's agria mother tincture. So there are so many processes. We have electromagnetic process, we have chemical process, we have bio weapon, we have what we can say the green synthesis. It is one of the very popular name in the field of nanotechnology. So here we want to make a different direction, and what we can say the pattern of arrangement of such atoms and molecules in the material science. So these are the dynamics of such molecules along with the electrons. Now next you can see the coarse grain. So this coarse grain, generally they processes and they showcase the properties of material, a coarse particle. So it is again at the different length, at the different temperature, at the different time, at the different velocity, at the different momentum. So you can see this coarse grain. Next, when we go for this electromagnetic or the scanning of such a coarse grain, you can see engineering devices. This engineering devices plays a major role for scanning such pattern of coarse grain. Therefore, there is a what we can say the integration of engineering science or engineering devices with the bioweapon, with the molecular science, with the material science. So these engineering devices helps in a scanning and making a image and the pattern of arrangement of this coarse grain or these metals or these atoms or these materials or these molecules, these electrons. So they will give you scanning, they will give you a specific flow of traveling such mass particle from one space, that is a up to b up to c up to d. So this is the application of such tool. Suppose if we talk about MRI, suppose if we talk about CT scan, so these are the different designs. Okay, these are the different mechanics. So this will give you the spectrum of such cellular structure, such epithelial, such tissue, such biosamples. So while scanning and probing such bioweapons, we need such tools which showcase you the different images in three-dimensional, not in two-dimensional. In X-ray, in sonography, this is generally in a X and Y axis, whereas in CT scan and MRI, we have three-dimensional view. X, Y, Z. So these are the engineering devices. Again, these are at different temperature, different pattern. So here the conclusion is at different nano, at different length, at different microns, this material dose, this material and this particle showcase a different properties. At 10 nanometer, it shows different properties. At 20 nanometer, it shows different property. At 30 nanometer, it shows different property. Why? Because their pattern of arrangement, their stability changes as per the length, as per the mechanism of dynamization, as per the mechanism of trituration, as per the mechanism of succussion. So their property changes as per the length, and this process of succussion, trituration, dynamization mechanics, again it correspond with the particular time, small t. So this is a basic properties of material science. That's why every material behaves differently at different length, at different structure, at different atoms, at different molecular pattern. Similarly, suppose if we have atropine. So atropine is a active principle of mother tincture in belladonna. Okay, so in belladonna the active principle is atropine. So the physics and the chemical property and the quantum mechanics of this atropine in mother tincture is different. When we talk about belladonna 200, so now the quantum mechanics and the atomic and the molecular dimension, not atomic, molecular, the massless structure, the isotopic propagation of this atropine in 200 in belladonna 200 is different. So these are the different level of explanation in the material science that we want to need, that we want to showcase, because ultimately the therapeutic action, the efficacy of belladonna in the therapeutic way is only because of the atropine, is only because of the belladine. So these are the active principle, these are the secondary metabolite, and we want that action only. We don't want primary action, because primary actions are not needed for the therapeutic purpose. We need the secondary one. So the secondary one plays a major role. Suppose in thuja oxidantase, the active principle is thujon. So this thujon plays a major role. So we want the quantum mechanics of thujon, which have two variety, alpha and beta thujon in mother tincture, alpha and beta thujon in 30, alpha and beta thujon in 200, alpha and beta thujon in 1m, alpha and beta thujon in ultra high dilution. So only that we can say yes, this material doses, this material property exhibits different physical, chemical and dynamics at different level of the potentization or dynamization that we want. Next is, now you can see the special issues. These are generally a matter for healthcare, in which we talk about the microstructure, the processing services, well-being. So what we can do when we talk about the artificial implantation of certain metals or artificial pacemaker or a joint replacement. So here again there is a material science. So this material science again exhibit with the different physical property, with the different chemical property, with the different electromagnetic property, with the different dynamics, with the different pattern of arrangement. It gives you a different pattern in a 3D printing, in a 2D printing. It gives you a different planification of metals. What is planification of metals? Generally it is the implantation of such metallic phase into the biological weapon. So these are the implication of such metals into the living entity. So these are generally a special issue regarding with the material science. Suppose if we have an artificial valve for replacing the dead or unfunctional valve in our heart. So these are the generally a metallic, what we can say, a material dose. So this metallic and the material dose exhibit a different function, exhibit a different dynamics, exhibit a different arrangements with the living world. So these are again a special issue for the material science, and nowadays it is very common. Nowadays we have knee replacement with the metal, we have a different bone replacement, wall replacement. So these are very common terminology, and these are very common application in a biomedical sciences. So these are the application of material science in a bioweapon. Next, now where is the enzyme? Now this enzymatic action plays a major role. So what it does? So enzymes it used for biosynthesis of material. Again, when we have material, so these enzymes when it combines with material, so they generally synthesize such material, which is known as a biosynthesis, because these are a bioweapon. Next is biodegradation of material. The degradation, the level of degradation is again because of the enzymes, because it causes catalytic action. It dissolves, it digests. So because of the level of digestion, because of the level of catalyzation, it causes biodegradation of such materials. Next is the biocompatibility of material. The biocompatibility is the compatibility of different substance or solute and the solvent in their physics, in their chemical, in their dynamics, in their electromagnetic field. So this is the biocompatibility of material. Suppose if we mix drug in a vehicle, so there should be a biocompatibility. If there is no compatibility, it does not show any specific dynamic, any specific action, any specific application to a living world. So this biocompatibility is again because of the enzyme. Next is the bioresponses of material. So again, this bioresponses of material plays a major role. So again, these are the responses of such molecular and the material dose towards a specific area, because every material showcases a specific action to a specific area. There are some cluster material, there are some minute structure or smartest or what we can say the sophisticated sensor which are showing a specific response to a specific place. So these are again because of the enzymatic action. The next is again the biosensor, as we know. And next is the immobilization of enzymes. So these are again important aspect, and the synthesis of material precursor. So these are basic aspect for making the union of this enzymatic action with the material action. So while combining this enzyme with the material's property, so they are showcasing such following properties. What are the following properties? Biosynthesis of material, biodegradation of material, biocompatibility of material, bioresponses, biosensors, immobilization, synthesis of material precursor, and grafting and coating of material. So this grafting and the coating of material, again it exhibits and release a different levels of the memory. So this is the grafting. When we graft, when we have the replacement of one layer of sheet into another one. So this is the grafting. So while doing this grafting, enzymes plays a major role because it gives you a platform to make a union. So this is the enzymatic action. Again, it plays a very huge role. Next is the application of advanced material. So in application part, we have a medicine, we have a space exploration, we have a sustainable energy, sustainable environment, we have a wearable technology, and the environmental remediation. So these are generally the various aspects of the application of such material. Here the most important is the medicine part. So when we make a mixture, suppose we make a plus B plus C. So when it form D, so this is the compounding. Okay, when we mix A plus B plus C and when it forms ABC, so it is a combining. It is not compounding. So similarly in the mixture and the preparation of various tablet trituration or capsules or any medicine, any formulary. So this advanced material plays a major role. So we want to know about the compatibility of A with B, compatibility of B with C, compatibility of A, B, C together. So if there is a compatibility of A with B, B with C with A, B with A, so that they form compounding, they form C, which is the synergistic effect, and that we want. If A is not compatible with, if B is not compatible with C, so they form a simple mixture. So there is no utility and there is no advantage of such mixture. In the market, we have so many external application, like we have shampoo, we have ointment, we have lotion, we have ophthalmic suspension, we have cream, we have dye, we have so many external application. How many of them are patent, registered for patent? So this is a question mark in our homeopathy. Okay, so many of the GMP certified pharmaceutical company, they prepare so many mixtures, so many medicine in a different form in a different dosage. But we want the synergistic action. We want a specific action from that particular biomolecule. so that we want to showcase the beauty of homeopathy. So this is the application of advanced material in the field of medicine. Next is the designing. Now, when we talk about the material science, so first we want to create a design. So design means the mixture, the propagation of a solute and the solvent. So when we talk about medicine, so design plays a major role. Design talks about the solute concentration, design talk about the solvent concentration, design talk about the other precursor concentration. So these are the design. Processing, how we prepare it. So suppose if we prepare the process of trituration, process of dynamization, so these are the processing. Microstructure, these are very minute and smallest particles. Now while preparing this, they have a different electrical property, they have a different magnetic property, they have a different physical property, they have a different magnetical property. So these are the different properties of different solute and the solvent mixture, a material dose. Now next is their performance. So we want to evaluate their efficacy in preclinical or clinical. When we talk about medicine, because we have homeopathic pharmacy, we have homeopathic medicine. So when we talk about homeopathic pharmacy, so we want to showcase the efficacy of homeopathic medicine in both preclinical and clinical trials. So these are their application. So in the performance, we are going to grade such minute and the microstructure in terms of their efficacy. So the efficacy parts plays a major role in performance. Then recycling. Okay, so this is the again cycling process to restore the previous physical and the chemical property. So these are the recycling. Moving towards next. Now, this is one of our research work from Parul University. We completed one of the research work. It is already published article, a synthesis of Echinacea mother tincture nanoparticle in the oil base by potentization under standardization by scanning electron microscope and compositional determination by EDS. So what we completed, we have Echinacea nanoparticle in an oil base, and scanning were done by the electron microscope or EDS, that is for compositional determination. So this article is already published in International Journal of Chemical Research and Development. It is one of the multidisciplinary journal and peer review journal. So that we already completed now. And these are the images. These are the true image. It is not copied by any Google and any website. It is seen in our published paper. These are the EDS scanning. These are the compositional difference. Now you can see in this compositional difference, the carbon and oxygen weight percentage, the sigma percentage, that is 0.54 is for carbon and 0.54 again weight percentage sigma for oxygen. But in weight percentage you can see difference, 50.62 is for carbon and 49.38 for oxygen. And the atomic percentage is also different for carbon and atom. For a carbon, that is 57.72, and for oxygen 42.28. So this is all about our experimentation part. We also completed this research work in the Parul University, and we are thankful to Micro Nano department for showcasing such research work with homeopathy. Thank you so much.
Thank you, Dr. Dr. Suraj Singh Bhadoria. It's really a very good session, really a motivating session to all. And as we all know that homeopathy is second to none. It is the pure science among all sciences. But unfortunately, these things are not coming to the notice of the so-called scientific community. So people like you can take this as a challenge, even though our CCRH is doing wonderful job in publishing their results in their website. Unfortunately, even the homeopathic doctors are also are not visiting the site. So I'm requesting all of you to see the sites and see how homeopathy works and how the homeopathic research work is going on everywhere. And we have lot of young generation doctors on the caliber of this Suraj Singh Bhadoria to give explanation to all. And I am inviting Dr. Rambaraj Sir to say what are thanks to the session.
Thank you, Dr. Dhanesh ji. Everyone, namaskar and congratulations. Dr. Suraj Singh Bhadoria. Very nice, dynamic lectures and dynamic personality, IFPH guest. So very very thanks and deals the pharmacy material science. Good describe the material science, electrical, chemical, and mechanical engineering, working in material science and dynamization, nanotechnology, medicine, quantum physics. Very good describe the presentation, material science. Very, very thanks, Dr. Suraj Singh Bhadoria,
Thank you, sir.
behalf of IFPH whole team. Again, presentation. Very, very thanks. Ghar Ghar Homeopathic, Ghar Ghar Homeopathic. Thank you.
Thank you so much, sir. Your words are very keen for me, sir.
Thank you, Dr. Ramdas, sir, and those who Dr. Surya Singh Bahodia, and those who attend the session this evening. Tomorrow we will have a session from Dr. Ruchi Mehta, and she will be talking about the best flower remedies. So, with that, we come to the end of the day 1924. Over to Dr. Mariamma John to moderate the Malayalam session. Thank you all. Good night.
നന്ദി ധനേഷ് ഡോക്ടറെ. എല്ലാവർക്കും നമസ്കാരം. IFPHന്റെ 1924 പ്രതിദിന സൂം വെബിനാറിലേക്ക് എല്ലാവരെയും സ്വാഗതം ചെയ്തുകൊള്ളുന്നു. ഇന്ന് നമ്മുടെ ക്ലാസ് ആരംഭിക്കുന്നതിന് മുൻപ് ഒരു നിമിഷം ഈശ്വര പ്രാർത്ഥന. നന്ദി. ഇന്ന് നമുക്ക് അതിഥിയായി എത്തുന്നത് ഡോക്ടർ ജോളി ജനാർദ്ദനൻ മാഡമാണ്. നമ്മുടെ ഈ പ്ലാറ്റ്ഫോമിൽ ആദ്യമായി എത്തുന്ന ജോളി ഡോക്ടറെ IFPH കുടുംബത്തിലേക്ക് പ്രത്യേകം സ്വാഗതം ചെയ്തുകൊള്ളുന്നു. ജോളി ഡോക്ടർ ഗവൺമെന്റ് ഹോമിയോ ആശുപത്രി തൃശ്ശൂരിൽ നിന്നും സൂപ്രണ്ടായി വിരമിച്ചു. വിരമിച്ചതിന് ശേഷം തൃശ്ശൂർ മുളങ്ങത്തുകാവ് പയ്യപ്പാട് വീട്ടിൽ സ്വന്തം വീട്ടിൽ ചികിത്സ തുടരുന്നു. ISKയുടെ ടീച്ചിങ് ഫാക്കൽറ്റിയും മറ്റ് സംഘടനകളിൽ വിവിധ വിഷയങ്ങളിൽ ക്ലാസുകൾ എടുത്തിട്ടുള്ള വ്യക്തിത്വം. 43 വർഷത്തിലധികം ചികിത്സാ പരിചയം. ഇന്നത്തെ വിഷയം ഓട്ടോ ഇമ്മ്യൂൺ രോഗങ്ങളും ഹോമിയോപ്പതിയും, 1ാം ഭാഗം, സന്ധിവാതം. ഈ വിഷയത്തിൽ ക്ലാസ് എടുക്കുന്നതിന് ഡോക്ടർ ജോളി ജനാർദ്ദനൻ മാഡത്തെ ആദരപൂർവം സ്നേഹപൂർവം ഈ പ്ലാറ്റ്ഫോമിലേക്ക് സ്വാഗതം ചെയ്തുകൊള്ളുന്നു. ഡോക്ടർക്ക് ആരംഭിക്കാം.
വീഡിയോ ഓൺ ആക്കിയിട്ടില്ല. ഡോക്ടർ കോഹോസ്റ്റ് ആണ്. ഡയറക്റ്റ് അൺമ്യൂട്ട് ചെയ്ത് സംസാരിക്കുക.